the man, he's the myth, he's the legend, he's the scientist with all the answers to all the questions. It's time for another episode of Alex's Science Corner.
Oh, thank you. No, please, thank you.
What's going on in the wide world of science, my friend?
So I've just got one story today. It's about some research that came out of the University of Glasgow, and it's about the regolith of the moon. So, do you guys remember anything about the term regolith?
No.
That is the dirt of the moon, and it's not like the normal dust and dirt we have here on Earth. The reason is because there's no atmosphere on the moon. Whenever meteorites hit, it smashes up the rocks that come in. It smashes up the moon, and so you've got this ultra-fine dust of glass and very sharp rocks that don't get abraded. And so these are very, very sharp rocks, tiny dust particles, and they stick to literally everything because they just jam into the clothing, into space suits. And that was one of the big problems that the astronauts had.
Okay, I got a question. Does the dust, it doesn't just, since there's no atmosphere, just go out into space?
Well, there's gravity.
So it'll keep some of the dust on the...
It will come back down.
Okay.
Okay, it just doesn't float in, like dust floats in the atmosphere because wind can push it around. There's no wind on the moon. So when the moon's gravity pulls it back down again. So it comes down as fast as dropping of a feather or a bowling ball would because it's a vacuum.
Okay.
So back to regolith. One of the things about the regolith, the particles are made up of metal and oxygen. Oxygen is such a big part of the regolith. It's about 45% of the weight of the regolith, which is the rocks or that dust of the moon. So one of the things that they had been hoping to do is if they start a moon colony, try to pull the oxygen and the metals apart so that you got the metals for building stuff and you got the oxygen for breathing. Because the less stuff you have to drag from Earth and have on the moon, the less stuff that you have to have on a rocket ship and carrying all that fuel to drag it over.
Sense.
Yeah. Now, one of the big problems is trying to separate out the oxygen from the metals, because that's a very, very power-intensive process. And so what these researchers have done is they've discovered a new method that cuts down the power usage to 1/3 of what it had been before. Now, do you remember that old experiment from high school when you would put water and you'd have these two tubes and there'd be a wire sticking in one tube and a wire sticking in the other tube, and you'd put current through it, and then you'd have oxygen in one cylinder?
I don't remember doing that one.
You never took high school chemistry.
Yeah,
okay.
I did.
They didn't have chemistry back then.
Okay.
Thanks a lot. Yes,
It was-
they did.
it was just the four elements,
it was just a
earth,
poor
fire, air, and
all-girls
water.
School. It was
Yeah.
a poor all-girls school. Go ahead. So
there's- so what they're
a
doing
chemistry
is-
experiment that you
The
can do.
50s
So they're
was
doing-
a different time, Alex.
Yes.
I didn't live then.
All right, this is a great edit point right here. All right, so what this process is you have an anode and a cathode, and that method would be able to separate oxygen from the hydrogen. So you'd have hydrogen in one tube and you'd have oxygen in the other tube. So they're doing the same sort of method for this, where they make these rocks molten, and they're going to be separating out the oxygen from the metals. So you have metals forming around one of the cathodes, and on the anode you'd have the oxygen. I may have those mixed up, but you'd have oxygen coming out. Now, this process takes between 15 to 50 hours for it to do this sort of thing, but it can separate out the metals and the oxygen from each other much, much better than what it used to. Here on Earth, when we do that, there's a lot of other chemical processes. For example, when we're making iron, you're not going to find iron naturally on the Earth. You're going to find it as iron oxide. The other way of describing that is rust. So oxygen and metal love to congregate together, and that's how rust forms. That's why you're not going to normally find just iron around, because if iron gets in contact with oxygen, it likes to form this rust or iron oxide, and oxygen loves to do that to metals. And that's what's happened to all these rocks on the moon. So that's why they found this method, so that hopefully we won't have to transport all these metals. Once we get the production facility set up, we'll be able to get oxygen and metals directly from the lunar soil.
From the moon.
Yeah.
Okay. Anything else to add?
Any other questions about that?
Yeah, so you said they have to melt the rock first.
Now the difference is between what they had to do prior to the new method. It had to be like, let me see here, 15 or 1600 degrees centigrade or 2900 degrees Fahrenheit that they had to get the rocks up to be able to do the separation. The new method is only 950 degrees centigrade or 1700 degrees Fahrenheit, which is a lot less power that you have to put in to do that.
So that's where the savings comes.
Right.
Okay.
Right.
Okay. All right. If you have any questions about this story or anything else science related, feel free to call right now at 203
837
99
24